On face. Voiceover off.
Good day, I'm Carrie. I just wanted to break protocol and actually appear to prove to people that I do exist in a physical space, and also because since I normally wear sunglasses because I'm legally blind, I wanted to prove that I actually have eyes. So they're not much use to me, but here they are. And last but not least, I wanted to make sure to promote National Music Center. Support the arts. In exchange for freedom of inquiry, scientists are obliged to explain their work. If science is considered a closed priesthood, too difficult and arcane for the average person to understand, the dangers of abuse are greater. But if science is a topic of general interest and concern, if both its delights and its social consequences are discussed regularly and competently in the schools, the press, and at the dinner table, we have greatly improved our prospects for learning how the world really is and for improving both it and us. That's my man, Carl Sagan, world famous astronomer and astrophysicist.
Reader available.
From his
Reader
book
available.
called Broca's Brain, which won a Pulitzer Prize. He published that in 1979. As you can see on this page here, he did lots of other things than just write this book and become an astronomer. He spent a great deal of his time trying to popularize and broaden the extent and usefulness of science in all of its all its sort of wonders, and to a small part that's what we're trying to do here as well. So a little bit of housekeeping first. I am ignoring my very first rule of doing presentations, which is not to rely on technology too heavily. I am buried up to my eyeballs in technology, and so if the screen freezes or the sound stops or you hear me start to cry for some reason, just turn off your browser and go finish your tea or your beer somewhere else, and we'll just try to forget that this ever happened, okay? If it was a live presentation, at this point I would ask you to silence your phones. As you very likely could be watching this on your phone, please don't silence your phone. In that same regard, if it was live, you would see me wearing sunglasses, as you may have heard in the introduction. That's because I am legally blind, and that is why I'm relying so heavily on technology. Consequently, you'll be hearing my iPad, named Esmeralda, speak a great deal. I've tried to choose and customize the voice so that it is both easy to understand and yet interesting to listen to, and she does really well, except some of the scientific notation becomes a bit of a challenge for her, and some of the grammatical nuances. But most of the time you'll be seeing it on screen as she's reading it, so it shouldn't be too much of a difficulty, so don't despair. And if it's really problematic, send me an email. So who am I? My name is Kerry Rutherford.
Website not secure.
That's Esmeralda. Born and raised in Calgary. I publish an online music performance magazine named Music Alive, which is centered in Calgary and Canada. And then the business that this presentation is based on is a separate one that I've started called A Talking Game. I've always been a science geek from childhood. Many of my family members or friends would have heard me say at some point or other that the only person cooler than Bono is Carl Sagan, and I've already explained that, so I won't go into that too much. I'm pretty fond of you two, but Carl Sagan. Anyway. I have a master's degree in communication, and I've also been published academically myself, which means that when I saw this website...
4032110.
Not mine. When I saw the Intergovernmental Panel on Climate Change's website, which I was drawn to because of my interest in science, I was really aghast at how mired and incomprehensible scientific jargon it can be, which is why nobody knows what they're talking about most of the time. with my interest in science and my own publishing background, I understand a lot of what they're talking about, but also as a communicator, I understand why no one else does. So I'm kind of perfectly positioned to stand as a bridge between the information available on their official website and the greater public who want to know what the heck they're going on about. And so that's where I am and where we are right now. Oh, you also may hear my iPhone. That's my cue card, and I have to listen to get through this stuff. That's that little voice in the background. It's not a mosquito. So I need to apologize for this being a text-heavy presentation because there is so much information available online, as I explained anyways, elsewhere. Everything one can get more information than they can possibly use. So the importance is to get curated, credible, verifiable information that you can determine its verifiability. And also, being legally blind, I'm not real good with charts and diagrams, so it wouldn't do me much good to be pointing at something when I'd probably be pointing at the wrong spot. So, and charts and diagrams have a certain level of interpretation involved. So if I stick with the words that the IPCC have actually presented, then we have a great deal better chance to sort of burrow down to exactly what they're talking about and hear what they have to say. So in that regard, my first presentation, which is available at YouTube, because of my desire to demonstrate who they are and why you should care, I spent half of the first presentation going into the history of the IPCC, talking about their backgrounds, breaking down basically their scientific credibility, so that during the last half of that presentation, and also during this one, that you would not then be worrying about where the information came from and able to focus more specifically on the information itself. I strongly recommend, if you haven't, if you don't know who the IPCC are, or you're not willing to just take their information, which you'll be seeing at face value, that you go stop this video and go check out this introduction, because as I said, we all have access to more information online than any person in previous history had access to, and we're overwhelmed with it, and a lot of it, as we all know, is crap. So you need to know the information is credible, and I go into that in great detail on that video. So that's a recommendation I have. So as I mentioned,
Menu, navigation,
I am going to be
actions available,
letting the IPCC speak for themselves almost entirely. All of the documents you'll be seeing from now on, except for specific things that I mentioned, all the documents you're looking at are their information. I have not changed the punctuation. I have not censored out certain words. I sometimes shorten them because the report we're looking at is 1,500 pages, and we can't spend the time to go through everything, so I shorten things, but you can see it being shortened because I show you the whole page as I'm skipping through it. So the information is there, and it will be their information that we're dealing with. So for example, we'll start with some facts and figures.
app switcher, Safari, active.
Now, just so you know exactly
Actions
what I'm doing, this is an app switcher on the iPad. It's showing, these are all Apple applications, just because that's how I roll. So Safari is an Apple internet
Actions
browser.
available.
We were just there a great deal.
Books.
We'll be in
Active.
books most of the time.
Actions available.
It's an Apple PDF and ebook reader. I've got over 1,000 documents on that, and I rely on it quite heavily.
Files.
And files
Active.
is cloud storage that Apple
Actions
provides,
available.
and it's all of the stuff on files is my stuff.
Files. 4 play. Play. App switcher. Play. Button. Play. Play. Button. Play. Files. Safari. Active. Books. Active. Books. The Working Group I Fact Sheet. The IPCC's Fifth Assessment Report. The Working Group I Contribution to the IPCC's Fifth Assessment Report, AR5, contains contributions from 3 working groups. Working Group I assesses the physical science basis of climate change. Working Group 2 assesses impacts, adaptation and vulnerability, while Working Group 3 assesses the mitigation of climate change. The synthesis report draws on the assessments made by all 3 working groups. The Working Group I contribution to the AR5, WGI AR5, has 14 chapters, a technical summary and a summary for policymakers. The report includes an assessment of observations of the climate system, with separate chapters covering changes in the atmosphere and surface, the ocean and the cryosphere, as well as information from paleoclimate archives. There are chapters covering the carbon cycle, the science of clouds and aerosols, radiative forcing and sea level change. Coverage of climate change projections is extended by assessing both near-term and long-term projections. Climate phenomena such as monsoon and El Niño and their relevance for future regional climate change are assessed. An innovative feature of the WGIAR5 is the Atlas of Global and Regional Climate Projections, Annex I, which is intended to enhance accessibility for users and stakeholders. The WGIAR5 involved experts from around the world with expertise in the many different disciplines necessary to produce a comprehensive assessment of the physical science of climate change according to the approved chapter outlines. There were 209 lead authors and 50 review editors. More than 600 additional experts were invited by the lead authors of the report to be contributing authors and to provide additional specific knowledge or expertise in a given area. Lead authors and review editors were selected for their scientific and technical expertise in relation to the approved chapter outlines for the WGIAR5 from lists of experts nominated by governments and IPCC observer organizations. Regional and gender balance were also considered, as well as ensuring the involvement of experts who had not worked on IPCC assessments before. The author teams assessed thousands of sources of scientific and technical information in the course of their work on WGIAR5. Priority is given to peer-reviewed literature if available, and over 9,200 publications are cited in the WGI report. Library. Button. Library. Back button.
So, 209 lead authors were involved in developing this report. What you're looking at here is the chapter listing for the Working Group 1 report, the physical science basis. As it mentioned, there's 14 chapters. There's a lot of other ancillary stuff. There's 2 of these things are mine, but most of the rest of it is part of the report. All of this stuff, as I've said before, is available on their website. And so this accumulation is 1,500 pages worth of stuff. 9,000 peer-reviewed articles are cited in this report, and since a 1,500-page article is too big for most policymakers to be able to read realistically, they produce a summary for policymakers.
Recent. List view. WG SPM summary for policymakers.
Which is, I believe, 28 pages
96% finished.
in total,
Button.
and that's what we'll be looking at. It summarizes all of the other material as that fact sheet, which was one of their fact sheets, as I've already said. So the summary for policymakers summarizes this other information, and we're going to look at that.
Library. Button.
Now I'm going to point out here that we're starting on page 27 because there's some useful information that you should have before going through the beginning of this summary, which is sadly at the very end. More importantly, this is a very long presentation, embarrassingly long. So I'm going to recommend that if your coffee is empty, or if you're still looking for another cookie, that you take a break right now. I don't know, pour the rest of the beer into your glass, whatever your, tea, smoke, whatever you need to do. Take 2 minutes right now, because I'm going to stop a couple times and give you a break, and I'll be here when you get back, I promise. See, I'm still here. Okay, now we're getting into the nitty-gritty of this. As I said, we're starting farther on so we can address some definitions that you're going to need throughout this process.
Bullet sustained. Bullet met. Box SPM. 1. Representative concentration pathways, RCPs.
Representative concentration pathways. You'll be hearing about these through the entire report, and so I'm not going to explain everything in extraordinary detail, but I will be giving you, I hope, a bit of a leg to stand on.
Climate change projections in IPCC Working Group I require information about future emissions or concentrations of greenhouse gases, aerosols and other climate drivers. This information is often expressed as a scenario of human activities, which are not assessed in this report. Scenarios used in Working Group I have focused on anthropogenic emissions and do not include changes in natural drivers such as solar or volcanic forcing or natural emissions, for example, of CH4 and N2O.
As a beginning, anthropogenic means human created. So climate change there's both natural climate change and anthropogenic climate change. Stuff that we've caused is anthropogenic. I mean, there's lots of climate change. There's seasons, there's cycles of ice ages. All those are natural climate change. Anthropogenic is human caused. In that regard, forcing is a term that refers to something that adds energy into a system, adds energy into a system. So they mentioned volcanic forcing, solar forcing. There's also orbital forcing. There's anything. So a system, choose a system. Well, the Earth, the globe in space is a system, and so the sun's heat entering the Earth's atmosphere and doing whatever it does, that energy is solar forcing. So the stuff coming in is the forcing itself. What happens once it's inside is caused by solar forcing. Volcanic forcing, as in opposition to that, when a volcano erupts, the combination of both the smoke and the clouds and aerosols that it produces actually cause the Earth to cool. So, which I didn't know before this. So volcanic forcing causes cooling in a climate system. Solar forcing generally causes heating because the energy is generally, it produces heat energy. There's also light energy. Part of the solar forcing is light energy. Heck, I mean, if you wanted to call it shower forcing, when I go into a pool or come out of a pool and I go into the shower room, the water, it's both its effects because of it falling from the shower head and its temperature and the fact that it's water and it causes things to dissolve. Those are all, that would be shower forcing on my system. And they talk about forcing a great deal in many different ways. For example, also orbital forcing, they mention it. So the orbit of the Earth is not a circle, it's an oval. So it changes our distance from the sun changes, and so the orbital forcing is the fact that it changes the impact of the sun on us. So the solar forcing is affected by the orbital forcing, and so orbital forcing is the thing. Yeah. Onward.
For the fifth assessment report of IPCC, the scientific community has defined a set of 4 new scenarios, denoted representative concentration pathways, RCPs, see glossary. They are identified by their approximate total radiative forcing in year 2100 relative to 1750, 2.6 W, M2 for RCP 2.6, 4.5 W, M2 for RCP 4.5, 6.0 W, M2 for RCP 6.0, and 8.5 W, M2 for RCP 8.5. For the coupled model into comparison project phase 5, CMIP 5, results, these values should be understood as indicative only. As the climate forcing resulting from all drivers varies between models, due to specific model characteristics and treatment of short-lived climate forces. These four RCPs include 1. Mitigation scenario leading to a very low forcing level, RCP 2.6, 2 stabilization scenarios, RCP 4.5 and RCP 6, and 1 scenario with very high greenhouse gas emissions, RCP 8.5. The RCPs can thus represent a range of 21st century climate policies, as compared with the no climate policy of the Special Report on Emissions Scenarios, SRES, used in the Third Assessment Report and the Fourth Assessment Report. For RCP 6.0 and RCP 8.5, radiative forcing does not peak by year 2100, for RCP 2.6 it peaks and declines, and for RCP 4.5 it stabilizes by 2100. Each RCP provides spatially resolved datasets of land use change and sector-based emissions of air pollutants, and it specifies annual greenhouse gas concentrations and anthropogenic emissions up to 2100. RCPs are based on a combination of integrated assessment models, simple climate models, atmospheric chemistry and global carbon cycle models. While the RCPs span a wide range of total forcing values, they do not cover the full range of emissions in the literature, particularly for aerosols.
So, my second apology already. This is the longest paragraph that we will encounter ourselves in this presentation, so I'm sorry it came so soon. So representative concentration pathways, the IPCC talks a great deal about pathways. As it mentions with the scenarios, a climate is a very complex system, and so any result has a large number of contributing factors. And so what the IPCC has done with others is they choose to determine pathways that lead to particular results. So in this case, the representative concentration is the concentration of CO2 in the atmosphere. Notice that the numbers, the 2.6, the 4.5, 6.0, and 8.5, I think, those are not temperatures, those are concentrations. Those are stabilization amounts. So watts per meter squared is an energy concentration at the year 2100, which is just a time post they've chosen. So at 2100, the 4.5 watts per meter squared RCP will have a certain amount, and they talk later on how much they predict it to be, a certain amount of carbon that will produce 4.5 watts per meter squared at the year 2100. And 6.0, same idea. They mentioned that 2.6 is low enough that by 2100 it will have reached its peak and then started to decline slightly, and that 4.5 stabilizes, so 4.5 watts per meter squared based on its CO2 contribution will stabilize before 2100, and 6.0 and 8.5 continue to rise past 2100. So they make references to these. These are not things that you'll be using, needing to know the details of in particular, but they make references to them. You need to know a little bit about it anyway.
Most of the CMIP5 and Earth system model simulations were performed with prescribed CO2 concentrations, reaching 421 ppm, RCP 2.6, 538 ppm, RCP 4.5, 670 ppm, RCP 6.0, and 936 ppm, RCP 8.5, by the year 2100. Including also the prescribed concentrate, 27 of 28.
Okay, and I'm not going to go, I just want to point out here, so they mentioned the 2.6 RCP pathway is a 420 parts per million CO2 equivalent. Currently we're at approximately 390. So that scenario allows for, if we reached 420 and stopped, then we would presumably have that watts per meter squared, as opposed to the 900 and some for 8.6, which would continue to rise past 2100. Pardon me. And I've already noticed something that I forgot to do, so I'm going to do that right now.
Library button. Library, recent button. List SPWG history of reports 1 history of report library button.
So something else that you need to be aware of as we go through this report is previous reports.
Page chooser 1 of 1. The IPCC is currently in its 6th assessment cycle, AR6, where it will prepare 3 special reports, a methodology report and the 6th assessment report.
So AR6, so the assessment report 6 is current, as in now. I'll point out that the report we're looking at today is actually from 2013. The introductory one that I mentioned before, that report is from 2018, so it's part of the AR6. It's one of the 3 special reports noted here. Notice that each one of these cycles are all 5 to 7 years apart. It starts in 1990. That's when the IPCC began to produce material originally. The report that we're in is, as I said, is
Assessment Report 5, AR5, was finalized between 2013 and 2014. It provided the scientific input into the Paris Agreement.
So the AR6 part there, it mentions there's 3 special reports, working group reports, and methodology. So what we're looking at is one of the working group reports from AR5. During this report, it mentions the previous report a great deal because they assess what they've done previously, and they mention AR4 a great deal. You can see
Assessment Report 4, AR4, 2007 laid the groundwork for a post-Kyoto agreement, focusing on limiting warming to 2 degrees Celsius.
So 2007 is our report's predecessor, and then the one that we're looking at is from 2013 to 14. And I am aware that it's, of course, 2020 now, so there's a bit of time has passed. However, this is the physical sciences basis. Physical sciences don't change every year. The theories change over decades, but most of the stuff that we're looking at is entirely sound, and then the stuff that has some time sensitivity, I actually point that out and I skip over it. This again is one of their documents. All of the documentation that you see, it will be listed in the credentials for this video, including links to the actual page where you can find this information, download it, and look at it right from their website if you choose.
Library button. Library. SPM summary for policymakers. SPM library button. Library table of contents. Page 23, page 3 of 4, page 1 of 4, page 2. Page 2. The working group I contribution, the degree of certain, summary, bookmark, SPM 4, A, introduction. The working group I contribution to the IPCC's 5th assessment report, AR5, considers new evidence of climate change, based on many independent scientific analyses from observations of the climate system, paleoclimate archives. Theoretical studies of climate processes and simulations using climate models. It builds upon the working group I contribution to the IPCC's 4th assessment report, AR4, and incorporates subsequent new findings of research. As a component of the 5th assessment cycle, the IPCC Special Report on Managing the Risks of Extreme Events and Disasters to Advance Climate Change Adaptation, SREX, is an important basis for information on changing weather and climate extremes. This summary for policymakers, SPM, follows the structure of the Working Group I report. The narrative is supported by a series of overarching highlighted conclusions which, taken together, provide a concise summary. Main sections are introduced, with a brief paragraph in italics which outlines the methodological basis of the assessment. The degree of certainty and key findings in this assessment is based on the author team's evaluations of underlying scientific understanding and is expressed as a qualitative level of confidence, from very low to very high, and, when possible, probabilistically with a quantified likelihood, from exceptionally unlikely to virtually certain. Confidence in the validity of a finding is based on the type, amount, quality, and consistency of evidence, e.g., data, mechanistic understanding, theory, models, expert judgment, and the degree of agreement. 1. Probabilistic estimates of quantified measures of uncertainty in a finding are based on statistical analysis of observations or model results, or both, and expert judgment. 2. Where appropriate, findings are also formulated as statements of fact without using uncertainty qualifiers. See Chapter 1 and Box TS 1 for more details about the specific language the IPCC uses to communicate uncertainty.
So uncertainty, as they've said, is important for them to define. They use, and this is an IPCC specific thing, their confidence levels, high, medium, low confidence, are based, as they say, on data and agreement. So let's say there's something for which they have lots and lots and lots of data indicating a thing. So that would suggest not much uncertainty, but perhaps the researchers or the assessment, because remember they're assessing others' research. They do no primary research. The Intergovernmental Panel on Climate Change does not do primary research. They assess the world's climate science research. So those reports, the people looking at those reports may not agree on what those results mean. So if there's lots of data and low agreement, that would give a medium confidence result as an example, whereas there might be a certain event for which there's only a few points of data, maybe even 2 that can happen, but all the researchers feel very strongly that those are accurate and repeatable and will determine the future events. And so even though there's low data, because there's high agreement, the end result again would be medium to medium high confidence. And then they talk about their certainty or the likelihood, and they detail at the bottom of the page their percentages for different statements of likelihood. I want to point out, I find the language a little bit connotatively confusing, because when I hear something is likely, that doesn't seem very strong to me. However, when you consider that that's a 66 or better % chance of occurring, then likely becomes fairly likely. To me, it means more than just likely. Whereas, on the other hand, as it was mentioned in another report, less likely may not seem like it's going to happen to you, but if you're flying in a plane that has a slightly less likely or 33% chance of crashing, how likely are you to get into that plane? So please note that their terms for likelihood are statistically based, and as I said, they're there on the bottom. Yeah.
Warming of the 1 in the 2 in this summer. Page chooser, page 2, page 3. Bullet for the longest period. Summary. SPM 5. D 1 atmosphere. Bullet the globally averaged combined land and ocean surface temperature data as calculated by a linear trend, show a warming of 0.85, 0.65 to 1.06, 0 degrees Celsius 3, over the period 1880 to 2012, when multiple independently produced datasets exist. The total increase between the average of the 1850 to 1900 period and the 2003 to 2012 period is 0.78, 0.72 to 0.85, 0 degrees Celsius. Based on the single longest dataset available for, see figure SPM 1. Dot, left curly bracket 2.4 right curly bracket.
You're going to hear a lot about curly brackets. There's not much I can do about that. So the numbers in the curly brackets, what they are is
Library. Gotcha. Library.
They are the
library.
sections
Back
within the
button.
chapters. So remember, again, we're looking at a summary of these chapters. So 3.2 is in chapter.
WGI fact. What about the annex 3 index?
Anyway,
Annex 3
wherever chapter
glossary.
wherever chapter
Yes.
3 is,
Planton,
there's a section
80%
3.2,
finished.
and if you look,
Button.
when you look in the chapters, then they follow the paragraphs with not numbered citations. Then they give you actual report citations with an author and a page number. Again, 9,000 cited reports. So that's just
Annex 5 contributors
so you
to the
can
IPCC
look up
SPM summary for policymakers.
information to your wildest fancy
SPM summary for library.
afterwards.
Button.
I'll also point out temperature, well, ranges. They use ranges constantly throughout this report. The first number is a mean, an average number between of the range that follows, and it's the standard calculation of average. You know, you add the two numbers together and divide them by 2, or add the 5 together, divide them by 5. So the first number is a mean, and if you remember your high school stats, that's how we did that. They usually indicate temperature issues with a range of dates. And they discuss that later. It's never a single year. It's usually a 30-year averaging, and then they choose that average as the date, as the number they want to use. Sometimes it's 50, and last but not least, no, I'm not going to tell you that one yet.
Page chooser. Library. Bookmark. Summary. SPM 5. B. 1 atmos. Bullet for the longest period when calculation of regional trends is sufficiently complete, 1901 to 2012, almost the entire globe has experienced surface warming. See figure SPM 1. Left curly bracket 2.4 right curly bracket.
Notice that surface warming, they're not talking about the ground at your feet. Global mean surface temperature is where we live. So the atmosphere in which we live, up to 10 kilometers, this is where the temperatures are being measured. They're not interested in the temperature 20 feet underground. And the sea, the ocean has, there's a land surface temperature, which is, again, the area we live in. And there's a sea surface temperature, which, if I remember correctly, includes a certain distance under the surface of the water and above it. So surface temperature changes.
Bullet in addition to robust multi-decadal warming, global mean surface temperature exhibits substantial decadal and interannual variability, see figure SPM 1. Due to natural variability, trends based on short records are very sensitive to the beginning and end dates and do not in general reflect long-term climate trends. As one example, the rate of warming over the past 15 years, 1998 to 2012, 0.05, minus 0.05 to 0.15, 0 degrees Celsius per decade, which begins with a strong El Niño, is smaller than the rate calculated since 1951 to 2012, 0.12, 0.08 to 0.14, 0 degrees Celsius per decade, 5, left curly bracket 2.4 right curly bracket.
So again, global mean surface temperature is numberless points around the globe in the area that we live, so less than 10 kilometers because the air circulates quite a great deal, and the average global mean surface temperature. And they mention many times about how the shorter the time frame of measurement of reference, the less chance of accuracy that they demonstrate. They go for the longest terms, which is, again, as why I said, they usually go for a 30-year period and then choose an average from that total.
Bullet continental scale surface temperature reconstructions show, with high confidence, multi-decadal periods during the medieval climate anomaly, year 950 to 1250, that were in some regions as warm as in the late 20th century. These regional warm periods did not occur as coherently across regions as the warming in the late 20th century. High confidence. Left curly bracket 5.5 right curly bracket.
So there's a high confidence uncertainty measurement. The medieval climate anomaly is a certain period of time, as they mention, about 900 to 1200, whatever the dates are, where things were significantly warmer, and so it's been people question, well, it was warmer then, if it's warmer now it doesn't make a difference. Well, the point about the medieval climate anomaly, as they're saying, is that it turns out, unlike currently when the entire globe is warming, the medieval climate anomaly is regional. So there's several different regions which were not necessarily connected, which were warmer, and they also weren't warmer at exactly the same time. So there was specific regions and at specific times in that time period, but it was not all exactly simultaneous, and it certainly wasn't global. So it kind of reduces that significance, even though it was as warm as it is. It could have been as warm as it is right now.
It is virtually certain that globally the troposphere has warmed since the mid-20th century. More complete observations allow greater confidence in estimates of tropospheric temperature changes in the extratropical northern hemisphere than elsewhere. There is medium confidence in the rate of warming and its vertical structure in the northern hemisphere, extratropical troposphere, and low confidence elsewhere. Left curly bracket 2.4 right curly bracket.
So some atmosphere science here. The troposphere is the well-mixed air, winds, and lots of clouds moving around and stuff. The climate, the weather that we deal with up to about 10 kilometers, that's the troposphere. Above that, where the gases stratify out, they become layered, and they're no longer mixed, and it's a very different activity in the stratosphere. So that the top part above the troposphere is the stratosphere, because they're in strati, in layers, and then the troposphere is where we live up to 10 kilometers. And they mention at some points about well-mixed greenhouse gases. That's because there's also greenhouse gases in the stratosphere, but it's a different, it works differently there. And we're focused mostly on where we're living in the troposphere with well-mixed greenhouse gases.
Confidence in precipitation change averaged over global land areas since 1901 as low prior to 1951 and medium afterwards. Averaged over the mid-latitude land areas of the northern hemisphere, precipitation has increased since 1901, medium confidence before and high confidence after 1951. For other latitudes, area averaged long-term positive or negative trends have low confidence. See figure SPM 2, left curly bracket TSTFE 1, figure 2, 2.5 right curly bracket.
In the citation curly brackets there, the TS is the technical summary, which is I've read through one of them and it's very technical. So if you like the science stuff, I recommend reading the technical summary. So precipitation, notice they have low and medium confidence about its rates previous to 1951, I think. And they mention somewhere that mostly it's because of measurement issues. They didn't have accurate precipitation measurements in those time frames, and I'm assuming that you weren't able to preserve the results of precipitation in a measurement form for us to look at 100 years later. That's my assumption.
Changes in many extreme weather and climate events have been observed since about 1950. See table SPM 1.4, details. It is very likely that the number of cold days and nights has decreased and the number of warm days and nights has increased on the global scale. 6. It is likely that the frequency of heat waves has increased in large parts of Europe, Asia and Australia. There are likely more land regions where the number of heavy precipitation events has increased than where it has decreased. The frequency or intensity of heavy precipitation events has likely increased in North America and Europe. In other continents, confidence in changes in heavy precipitation events is at most medium. Left curly bracket 2.6 right curly bracket.
So I'll just mention again that likely means 66 to 100% chance of that being the case.
Each of the last 3 decades has been successively warmer at the Earth's surface than any preceding decade since 1850, see figure SPM 1. In the Northern Hemisphere, 1983 to 2012 was likely the warmest 30-year period of the last 1,400 years, medium confidence, left curly bracket 2.4, 5.3 right curly bracket.
There's one of those 30-year periods that they like to use as their standard, and anyway.
3 in the double, 4 both, 5, 6, 3 of 20, page chooser, page 4. 0.6, 0.4 of 20, page chooser, 4, figure SPM, 1 vertical line, observed global mean combined land and ocean surface temperature anomalies, from 1850 to 2012 from 3 data sets. 4 of 28, page chooser, page 4.
So as I mentioned,
adjustable.
I'm going to pause just for like 5 seconds on each figure that I can encounter, that my voiceover reads to me. So, feel free to pause and have a look. I'm not going to linger on them because I can't. Well, I can, but...
Page 5. Virtually likelihood of table SPM, 1 vertical line, page chooser, page 5. Adjust 5 of very likely 5 of 20, page chooser, page 5. Adjustable. Page 6. Observe figure S B. Bullet on a global scale, B, to ocean.
Unlike class in high school, you can eat cookies in class. I strongly recommend that you stop this video, grab a cookie, because I wish I had one. And you won't get a detention for eating cookies in class. I'll wait. Okay, we're back, as they say.
Bookmark B, to ocean. Bullet on a global scale, the ocean warming is largest near the surface, and the upper 75 meters warmed by 0.11, 0.09 to 0.13, 0 degrees Celsius, per decade over the period 1971 to 2010. Since AR5, instrumental biases in upper ocean temperature records have been identified and reduced, enhancing confidence in the assessment of change. Left curly bracket 3.2 right curly bracket.
So I like the fact that they're pointing out there were instrumental biases previously, and remember AR4 was published in 2007. So since then, they've been able to correct those instrumental biases. Scientists are good.
Bullet it is likely that the ocean warmed between 700 and 2,000 meters from 1957 to 2009. Sufficient observations are available for the period 1992 to 2005 for a global assessment of temperature change below 2,000 meters. There were, likely, no significant observed temperature trends between 2,000 and 3,000 meters for this period. It is likely that the ocean warmed from 3,000 meters to the bottom for this period, with the largest warming observed in the Southern Ocean. Left curly bracket 3.2 right curly bracket.
So just by reading this paragraph, I'm interested in the fact that during this particular period, from 700 to 2,000 meters warmed to some degree, but from 2 to 3,000 didn't warm, and then from 3,000 to the bottom of the ocean did warm. That's kind of fascinating to me. Also, the fact that they're talking about 2,000 meters below the surface of the ocean makes me feel extraordinarily claustrophobic, so we're going on.
Bullet more than 60% of the net energy increase in the climate system is stored in the upper ocean, 0-700 m, during the relatively well-sampled 40-year period from 1971 to 2010, and about 30% is stored in the ocean below 700 meters. The increase in upper ocean heat content during this time period estimated from a linear trend is likely 15 to 19 times 1022 J 7. See figure SPM 3. left curly bracket 3.2, box 3.1 right curly bracket.
So it's simple math. It's kind of crazy math to me, but it is saying that 60% of the heat energy is stored in the ocean above, 700 meters, and then below that is another 30% of the total increase in heat energy. So 90% of the the increased heat energy that is stored in the planet is stored in the ocean. So there's no surprise that there's changes in they call it expansion by heat, and also how that may affect the chemical balances in the ocean. But
Bulleted as, about as likely as not, that ocean heat content from 0-700 m increased more slowly during 2003 to 2010 than during 1993 to 2002. See figure SPM 3. Ocean heat uptake from 700-2000 m, where interannual variability is smaller, likely, continued unabated from 1993 to 2009 left curly bracket 3.2, box 9.2 right curly bracket.
they make many references to interannual variability. Basically, that's the year-to-year change in climate and its impact on lots of stuff. And so clearly, certain layers of the ocean are more impacted by that than other layers, and that's what that reference is.
Bulleted as, very likely, that regions of high salinity where evaporation dominates have become more saline, while regions of low salinity where precipitation dominates have become fresher since the 1950s. These regional trends in ocean salinity provide indirect evidence that evaporation and precipitation over the oceans have changed. Medium confidence. Left curly bracket 2.5, 3.3, 3.5 right curly bracket.
So yes, it's saying part of the ocean is getting more salty because of evaporation, and other parts are getting less salty because of precipitation. So you might say, well, then the total is zero. What's the big deal? But of course, water, the ocean's big, and the regional impact of increases or decreases in salinity is the issue. As always, once we're all gone, the climate can do what it likes. But the issue is what impact these climate changes have on the living systems that are there, and clearly they're indicating there is impacts.
Bullet. There is no observational evidence of a trend in the Atlantic meridional overturning circulation, AMIC, based on the decade-long record of the complete AMIC and longer records of individual AMIC components. Left curly bracket 3.6 right curly bracket.
So that's good news. Not much change in this thing, the AMIC. The Atlantic meridional overturning circulation is basically the ocean's highway system, how the currents move around in the one of the current assessment cycles reports, the special report on the ocean and cryosphere. There's an entire chapter on this thing, the overturning circulation, and it's fascinating. Not knowing anything about it beforehand, it was amazing to read about how water rises or sinks based on its salinity, based on its acidity, its temperature, how this causes it to move in different directions and creates currents and causes like the entire freeway network of the ocean. I highly recommend looking at it. It was amazing.
Observed change in annual precipitation over land 1901. 201011951 2010 -100 -50 -25 figure SPM 2 vertical line. Maps of observed precipitation changed from 1901 to 2010 and ocean 6 of 28. Page chooser. Page 7. Bullet the average B. Bullet the B. 3 cryosphere.
Cryosphere. That's frozen stuff. So glaciers on land, icebergs in the water, ice sheets, snow, frozen lakes, the permafrost, the tundra, anything that where the water is frozen specifically is the cryosphere.
Bullet the average rate of ice loss 8 from glaciers around the world, excluding glaciers on the periphery of the ice sheets 9, was very likely 226, 91 to 361, GT-1, over the period 1971 to 2009, and, very likely, 275, 140 to 410, GT-1 over the period 1993 to 200910. Left curly bracket 4.3 right curly bracket.
So what's a gigaton? Gigaton, gigaflop, gigajoule, Gigi goes to the beach. Gigi, what was her name? Anyways, old movie. So a gigaton is 1 billion tons. So 1 and 9 zeros, 1,000 million tons is what a gigaton is. Notice they're gigatons and not gigapounds. So metric tons, if you want to do the conversions, you can. But so what the heck is a gigaton? A billion tons. So I've seen lots of descriptions of how to sort of envision it, including like hundreds of thousands or millions of elephants and hundreds of thousands of whales. And the one I thought was simplest and still mind-boggling is that so the entire human race living now, so what is it, 7 billion people, 6.5 billion people, anyways, all of humanity currently alive would weigh a little bit less than 2 gigatons. So I think it was 1.6, if I remember correctly. I mean, it's an approximation, obviously, but so half of living humanity would be potentially less than 1 gigaton. And so when they mention 200 gigatons, notice also those are 200 gigatons per year in ice loss. So it's not 200 gigatons in total. So that's a lot of ice.
Bullet, the average rate of ice loss from the Greenland ice sheet has, very likely, substantially increased from 34, -6 to 74, GT-1, over the period 1992 to 2001 to 215, 157 to 274, GT-1, over the period 2002 to 2011 left curly bracket 4.4 right curly bracket.
A lot of ice. A lot of fresh water going into the ocean.
Bullet, the average rate of ice loss from the Antarctic ice sheet has, likely, increased from 30, -37 to 97, GT-1, over the period 1992 to 2001 to 147, 72 to 221, GT-1, over the period 2002 to 2011. There is very high confidence that these losses are mainly from the northern Antarctic Peninsula and the Amundsen Sea sector of West Antarctica. Left curly bracket 4.4 right curly bracket.
So I find it interesting to notice that the Greenland is actually losing ice faster than Antarctica is, and one can presume that's because it's warmer where Greenland is. They address this with the Arctic issues also, but and I had an idea about anyway, the South Pole, it looks like, is colder than the North, and so Greenland is losing more ice than Antarctica is, even though Antarctica is clearly tons bigger than Greenland.
Bullet, the annual mean Arctic sea ice extent decreased over the period 1979 to 2012 with a rate that was, very likely, in the range 3.5 to 4.1% per decade, range of 0.45 to 0.51 million km2 per decade, and, very likely, in the range 9.4 to 13.6% per decade, range of 0.73 to 1.07 million km2 per decade, for the summer sea ice minimum, perennial sea ice. The average decrease in decadal mean extent of Arctic sea ice has been most rapid in summer, high confidence. The spatial extent has decreased in every season, and in every successive decade since 1979, high confidence. See figure SPM 3. There is medium confidence from reconstructions that over the past 3 decades, Arctic summer sea ice retreat was Unprecedented and sea surface temperatures were anomalously high in at least the last 450 years. Left curly bracket 4.2, 5.5 right curly bracket.
So notice this is extent or surface area of the ice, how far the ice extends, as opposed to actual volume. So they're measuring it in kilometers squared. Percentages are associated with that. The fact that in the last 30 years the shrinkage has been, as they say, unprecedented, and the temperature has been also in the sea ice, in the sea has been, the Northern Sea has been unprecedented for at least the last 1400 years, is based on, you have to ask a climate scientist how they do that. It's paleo-archival measurements, and that's the Arctic, not the Antarctic.
It is very likely that the annual mean Antarctic sea ice extent increased at a rate in the range of 1.2 to 1.8% per decade, range of 0.13 to 0.20 million km2 per decade, between 1979 and 2012. There is high confidence that there are strong regional differences in this annual rate, with extent increasing in some regions and decreasing in others. Left curly bracket 4.2 right curly bracket.
So yes, Antarctica, as opposed to the Arctic, the extent is actually increasing, and that was a bit of a surprise for me to notice that. I had to read it twice, but then given that, and I'm not going to go to the place where it mentions about the South Pole being cooler than the North. You'll have to find it yourself, I'm afraid, but if it's colder than the North is, and keep in mind that what's happened with climate change and global warming is that as water evaporates, and there's more of it evaporating, it is in the air. The air has a higher moisture content, so if it's cold, that would present the chance for there to be more snow. So my assumption is that the Antarctic is getting extending because it's getting more snow on it because of the higher water amounts.
There is very high confidence that the extent of Northern Hemisphere snow cover has decreased since the mid-20th century. See figure SPM 3. Northern Hemisphere snow cover extent decreased 1.6, 0.8 to 2.4% per decade for March and April, and 11.7, 8.8 to 14.6% per decade for June, over the 1967 to 2012 period. During this period, snow cover extent in the Northern Hemisphere did not show a statistically significant increase in any month. Left curly bracket 4.5 right curly bracket.
No snowfall increases in any month. So much for skiing.
There is high confidence that permafrost temperatures have increased in most regions since the early 1980s. Observed warming was up to 3 degrees Celsius in parts of northern Alaska, early 1980s to mid-2000s, and up to 2 degrees Celsius in parts of the Russian, European North, 1971 to 2010. In the latter region, a considerable reduction in permafrost thickness and aerial extent has been observed over the period 1975 to 2005. Medium confidence. Left curly bracket 4.7 right curly bracket.
So the important thing to remember about permafrost and tundra melting is not just that you're going to sink into it, and it's that lots of dead stuff is in the frozen tundra and in the permafrost. So as those things melt, then that dead stuff can decay, and decaying organic matter creates methane. So I remember encountering a discussion of North America's melting tundra, and that when it melts, when it all goes soft, it will produce more methane than the rest of us do at all. So we in Canada will produce more from our melting tundra than the rest of the planet produces in methane. And methane is not CO2. It's not in such abundance as CO2. However, methane is also much more potent as a greenhouse gas. I've seen 30 to 80% more potent, 30 to 80 times more potent than carbon dioxide as a greenhouse gas. So having huge quantities of it emerge from the permafrost is not a great thing.
Multiple lines of evidence support very substantial Arctic warming since the mid-20th century. Left curly bracket box 5.1, 10.3 right curly bracket. Over the last 2 decades, the Greenland and Antarctic ice sheets have been losing mass, glaciers have continued to shrink almost worldwide, and Arctic sea ice and Northern Hemisphere spring snow cover have continued to decrease in extent. High confidence, see figure SPM, 3, left curly bracket 4.2 to 4.7 right curly bracket. 8 all reference, 9 for me, 1, 7 of 28, page chooser, page 8. 40, figure SPM, 3 vertical line, multiple observed indicators of a changing global climate, extent of Northern Hemisphere March-April, 8 of page choose, page 9. Library, share, S, markup, search, bookmarks, B, 4 sea level. Bullet proxy and instrumental sea level data indicate a transition in the late 19th to the early 20th century from relatively low, mean rates of rise over the previous 2 millennia to higher rates of rise, high confidence. It is likely that the rate of global mean sea level rise has continued to increase since the early 20th century, left curly bracket 3.7, 5.6, 13.2, bullet. It is very likely that the mean rate of global average sea level rise was 1.7, 1.5 to 1.9 mm year 1, between 1901 and 2010, 2.0, 1.7 to 2.3 mm year 1, between 1971 and 2010, and 3.2, 2.8 to 3.6 mm year 1, between 1993 and 2010. Tide gauge and satellite altimeter data are consistent regarding the higher rate of the latter period. It is likely that similarly high rates occurred between 1920 and 1950 left curly bracket 3.7 right curly bracket.
I was interested in how they calculate a 100-year sea level rise as an average. Well, it gives a lower annual average, but then when they break it down to 2 periods, both nearer to current times, the rate becomes higher. Also, just to point out, one criticism I've encountered is, well, what's 1 millimeter per year, or 2 millimeters per year for that matter? The point is, I don't know when's the last time you stood at an ocean and gazed out to the horizon at the water that can be surround you on 2 or 3 sides, depending on where you are, and then imagine that entire surface being a couple of millimeters higher every year, and imagine the vast quantity of water that must include. And also, because of that mass, because that would obviously be a massive amount of water, what changes it may have in ocean activity and climate activity.
Bullet. Since the early 1970s, glacier mass loss and ocean thermal expansion from warming together explain about 75% of the observed global mean sea level rise, high confidence. Over the period 1993 to 2010, global mean sea level rises, with high confidence, consistent with the sum of the observed contributions from ocean thermal expansion due to warming, 1.1, 0.8 to 1.4 mm, year 1, from changes in glaciers 0.76, 0.39 to 1.13 mm year 1, Greenland ice sheet, 0.33, 0.25 to 0.41 mm year 1, Antarctic ice sheet, 0.27, 0.16 to 0.38 mm, year 1, and land water storage, 0.38, 0.26 to 0.49 mm, year 1. The sum of these contributions is 2.8, 2.3 to 3.4 mm year 1, left curly bracket 13.3 right curly bracket.
So 2.8 millimeters per year when you total all those together. I found it interesting to see it broken down like that.
Bullet. There is very high confidence that maximum global mean sea level during the last interglacial period, 129,000 to 116,000 years ago, was, for several thousand years, at least 5 meters higher than present. And high confidence that it did not exceed 10 meters above present. During the last interglacial period, the Greenland ice sheet, very likely, contributed between 1.4 and 4.3 meters to the higher global mean sea level, implying with medium confidence, an additional contribution from the Antarctic ice sheet. This change in sea level occurred in the context of different orbital forcing and with high latitude surface temperature, averaged over several thousand years, at least 2 degrees Celsius warmer than present, high confidence. Dot. Left curly bracket 5.3, 5.6 right curly bracket.
So there's good news. During the previous to the last ice age, when it was warm, the last interglacial period they call it, so ice ages happen about every 100,000 years. So from 115 to 130,000 years ago was interglacial, and apparently the water did not get up to 10 meters higher than it is now, the sea level. It did get potentially 5 meters higher, the sea level, than it is now, and it mentions that that is potentially because of a 2 degree warmer than currently temperature increase. So 5 meters, is that okay as opposed to 10? It's great if you're in Calgary. We're at 3,000 feet above sea level. Is that? No, that's less than 5 miles. Oh, no, 5 meters. Sorry. So we're good. Yeah.
B. 5 carbon and other biogeochemical cycles. Bullet. The atmospheric concentrations of the greenhouse gases carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O, have all increased since 1750 due to human activity. In 2011, the concentrations of these greenhouse gases were 391 ppm 11, 1803 ppb, and 324 ppb, and exceeded the pre-industrial levels by about 40%, 150%, and 20%, respectively. Left curly bracket 2.2, 5.2, 6.1, 6.2 right curly bracket.
So let's address the pre-industrial period they keep talking about. The beginning of the Industrial Revolution is considered between 1750 and 1850. That's when our civilizations first started to really ramp up manufacturing and production and burn lots of fuels that, we needed lots of energy for the mechanical production of those factories. And so the pre-industrial period is before 1750, and so the IPCC and other climate scientists try to gauge levels currently compared to what it was like from their assessment of other data before 1750, which is why that date comes up. It'll come up a lot more during the rest of this. 1750 to 1850, they use it in different ways. Notice that it mentions that before 1750, so before we started all those looms, automated looms in, Netherlands and other stuff we were doing in Europe, before that, the CO2 levels, which will stick with CO2 because we have to finish this thing someday, were 40% lower than they are currently, and the numbers right now are 390 parts per million. Notice that the methane and the nitrous oxide numbers are parts per billion, not parts per million. But don't be dissuaded by that. As I pointed out, methane is potentially 80 times more potent than CO2, so a much smaller amount still has a significant impact.
Bullet concentrations of CO2, CH4, and N2O now substantially exceed the highest concentrations recorded in ice cores during the past 800,000 years. The mean rates of increase in atmospheric concentrations over the past century are, with very high confidence, unprecedented in the last 22,000 years. Left curly bracket 5.2, 6.1, 6.2 right curly bracket.
So those greenhouse gases are higher currently than scientists have been able to determine from ice cores over 800,000 years. But the change, the increase in their amounts is unprecedented in the last 22,000. So you can determine that as you wish, and there's the chapter reference. You can go look it up if you wish, if that's your thing. I'm not going to linger too much on these chemical aspects because it gets dense, and we do have lots to get through here, so forgive me.
The rate of sea level rise since the mid-19th century has been larger than the mean rate during the previous 2 millennia, high confidence. Over the period 1901 to 2010, global mean sea level rose by 0.19, 0.17 to 0.21 m, see figure SPM, 3, left curly bracket 3.7, 5.6. The atmospheric concentrations of carbon dioxide, methane, and nitrous oxide have increased to levels unprecedented in at least the last 800,000 years. Carbon dioxide concentrations have increased by 40% since pre-industrial times, primarily from fossil fuel emissions and secondarily from net land use change emissions. The ocean has absorbed about 30% of the emitted anthropogenic carbon dioxide, causing ocean acidification, see figure SPM, 4, left curly bracket 2.2, 3.8, 5.2, 6.2, 6.3 right curly bracket.
Notice the reference here to the ocean absorbing, it's not absorbing the heat, this is a reference to it absorbing actual CO2, and it has also absorbed up to 30% of the carbon dioxide that, the extra carbon dioxide, the carbon dioxide that's been produced, and that CO2 is the reason for the chemical changes ocean-wise.
11 ppm, 9 of 20, page chooser, page 10, bullet from 1000, bullet of these, bullet figure SPM, 4 vertical line, multiple observed indicators of a changing global carbon cycle, 12, 13 p, 10 of page chooser, page 11, natural at sea, drivers of climate change. Bullet the total anthropogenic RF for 2011 relative to 1750 is 2.29, 1.13 to 3.33, W, M-2, see figure SPM, 5, and it has increased more rapidly since 1970 than during prior decades. The total anthropogenic RF best estimate for 2011 is 43% higher than that reported in AR5 for the year 2005. This is caused by a combination of continued growth in most greenhouse gas concentrations and improved estimates of RF by aerosols indicating a weaker net cooling effect, negative RF, left curly bracket 8.5 right curly bracket.
So radiative forcing, right? Forcing is changes in an energy system. Radiative is, most likely the sun coming in. That's the most blatant form of radiation that the Earth receives. So radiative forcing, however, would be impacted by changes in the chemical structure of the atmosphere because, of course, if it's water vapor absorbs heat, it's a greenhouse gas. Most of our greenhouse gases are in fact water vapors, which is our balance. That's fine, that works. It's the additional chemicals that change that and change the radiative forcing thereby.
Bullet the RF from emissions of well-mixed greenhouse gases, CO2, CH4, N2O, and halocarbons, for 2011 relative to 1750 as 3.00, 2.22 to 3.78, W, M2, see figure SPM, 5. The RF from changes in concentrations in these gases is 2.83, 2.26 to 3.40, W, M2 left curly bracket 8.5 right curly bracket.
So you forgive me if you're one of the people who likes climbing into this kind of chemical calculation stuff. I'm going to assume, because this is going on long enough as it is, I'm going to assume that you can look at this at your leisure, because obviously it's on the page. You can just pause this and look at it when you wish, and I'm going to continue to move ahead.
Bullet the total radiated forcing is positive, and has led to an uptake of energy by the climate system. The largest contribution to total radiated forcing is caused by the increase in the atmospheric concentration of CO2 since 1750, see figure SPM, 5, left curly bracket 3.2, box 3.1, 8.14. The strength of drivers is 15, 11 of page chooser. Page 12, bullet the RF bullet the emit, figure SPM, 5 vertical line. Radiated forcing estimates in 2011 relative to 1750, 12 of page chooser. Page 13, understanding D. Understanding the climate system and its recent changes.
Time to chase down a cookie? If you didn't do it before, now's your last chance. I'm not going to be pausing this anymore. Well, I mean, you can pause it anytime you like, but I won't be specifically saying, go now. Chocolate bar, apple, sorry, it should be healthy. Get yourself a piece of celery, or that cookie. Okay, that was it. You blew your chance. Now we're moving onwards.
Understanding recent changes in the climate system results from combining observations, studies of feedback processes, and model simulations. Evaluation of the ability of climate models to simulate recent changes requires consideration of the state of all modeled climate system components at the start of the simulation and the natural and anthropogenic forcing used to drive the models. Compared to AR4, more detailed and longer observations and improved climate models now enable the attribution of a human contribution to detected changes in more climate system components. D1 Evaluation of climate models.
Now, because this report is from 2013, that is 7 years ago, it is 2020, so there's been significant changes in the modeling that's going on. It doesn't mean that this stuff they talk about is to be completely ignored, but I'm not going to go into these or some other sections later on that are more time sensitive because it's 2020. Now, of course, the information's on the page. If you're quite welcome to either just pause the video and read it here, or much more intelligent, frankly, would be to go to their website and download it and have a look at it without, anyways. So I'm going to speed up a little bit here because you have been watching this for a long time, you poor soul.
The long-term climate model simulations show a trend in global mean surface temperature from 1951 to 2012 that agrees with the observed trend. Very high confidence. There are, however, differences between simulated and observed trends over periods as short as 10 to 15 years, e.g., 1998 to 2012, left curly bracket 9.4, box 9.2 right curly bracket.
Short-term observations are less accurate than long-term observations in these models, which, I mean, stands up to the rest of what they're talking about anyways, so that was interesting to me.
Some human influence on the climate system is clear. This is evident from the increasing greenhouse gas concentrations in the atmosphere, positive radiative forcing, observed warming, and understanding of the climate system, left curly bracket 2-14 right curly bracket. Climate models have improved since the AR4. Models reproduce observed continental scale surface temperature patterns and trends over many decades, including the more rapid warming since the mid-20th century and the cooling immediately following large volcanic eruptions. Very high confidence, left curly bracket 9.4, 13 of 20, page chooser, page 14. There is climate, there is D, 2 quantify, climate models now, climate, D, 2 quantification of climate system responses. The net feedback from the combined effect of changes in water vapor, and differences between atmospheric and surface warming is extremely likely, positive, and therefore amplifies changes in climate. The net radiative feedback due to all cloud types combined is likely, positive. Uncertainty in the sign and magnitude of the cloud feedback is due primarily to continuing uncertainty in the impact of warming on low clouds, left curly bracket 7.2 right curly bracket.
A couple places in one of the more recent reports, recent cycle, mentioned the uncertainty that clouds cause in their climate projections and modeling projections.
The equilibrium climate sensitivity quantifies the response of the climate system to constant radiative forcing on multi-century time scales. It is defined as the change in global mean surface temperature at equilibrium that is caused by a doubling of the atmospheric CO2 concentration. Equilibrium climate sensitivity is likely in the range 1, 5 degrees Celsius to 4, 5 degrees Celsius, high confidence, extremely unlikely, less than 1 degree Celsius, high confidence, and very unlikely, greater than 6 degrees Celsius. Medium confidence, 16. The lower temperature limit of the assessed, likely, range is thus less than the 2 degrees Celsius in the AR4, but the upper limit is the same. This assessment reflects improved understanding, the extended temperature record in the atmosphere and ocean, and new estimates of radiative forcing, left curly bracket TSTFE, 6, figure 1, box 12.2 right curly bracket.
So I don't know about you, but by this point, my response is, what'd you just say? So again, I'm not going to linger on. These get more detailed, and there's more, as I said, there's other time-sensitive stuff which I'll be jumping over. The information's here if you wish it.
Bullet the rate, bullet the track, bullet A, observational and model studies of temperature change. Climate feedbacks and changes in the Earth's energy budget together provide confidence in the magnitude of global warming in response to past and future forcing. Left curly bracket box 12.2. 14 of 28. Page chooser. Page 15. D. 3 detection and attribution. Bullet various metrics can surface temperature change. Bullet D. 3 detection and attribution of climate change. D. 3 detection and attribution of climate change. Bulleted as extremely likely that more than half of the observed increase in global average surface temperature from 1951 to 2010 was caused by the anthropogenic increase in greenhouse gas concentrations and other anthropogenic forcings. Together, the best estimate of the human-induced contribution to warming is similar to the observed warming over this period. Left curly bracket 10.3 right curly bracket. Bullet greenhouse gases contributed a global mean surface warming, likely to be in the range of 0.5 degrees Celsius to 1.3 degrees Celsius over the period 1951 to 2010, with the contributions from other anthropogenic forcings, including the cooling effect of aerosols, likely to be in the range of -0.6 degrees Celsius to 0.1 degree Celsius. The contribution from natural forcings is likely to be in the range of -0.1 degree Celsius to 0.1 degree Celsius. And from natural internal variability is likely to be in the range of -0.1 degree Celsius to 0.1 degree Celsius. Together these assessed contributions are consistent with the observed warming of approximately 0.6 degrees Celsius to 0.7 degrees Celsius over this period. Left curly bracket 10.3 right curly bracket. Bullet over every continental region except Antarctica, anthropogenic forcings have, likely, made a substantial contribution to surface temperature increases since the mid-20th century. See figure SPM, 6. For Antarctica, large observational uncertainties result in low confidence that anthropogenic forcings have contributed to the observed warming averaged over available stations. It is likely that there has been an anthropogenic contribution to the very substantial Arctic warming since the mid-20th century. Left curly bracket 2.4, 10.3 right curly bracket. Bulleted as very likely that anthropogenic influence, particularly greenhouse gases and stratospheric ozone depletion, has led to a detectable observed pattern of tropospheric warming and a corresponding cooling in the lower stratosphere since 1961. Left curly bracket 2.4, 9.4, 10.3 right curly bracket. Bulleted as very likely that anthropogenic forcings have made a substantial contribution to increases in global upper ocean heat content 0-700 m observed since the 1970s. See figure SPM, 6. There is evidence for human influence in some individual ocean basins. Left curly bracket 3.2, 10.4 right curly bracket. Bulleted as likely that anthropogenic influences have affected the global water cycle since 1960. Anthropogenic influences have contributed to observed increases in atmospheric moisture content in the atmosphere, medium confidence, to global scale changes in precipitation patterns over land, medium confidence. To intensification of heavy precipitation over land, regions where data are sufficient, medium confidence, and to changes in surface and subsurface ocean salinity, very likely. Left curly bracket 2.5, 2.6, 3.3, 7.6, 10.3, 10.4 right curly bracket. Human influence has been detected in warming of the atmosphere and the ocean, in changes in the global water cycle, in reductions in snow and ice, in global mean sea level rise, and in changes in some climate extremes. See figure SPM 6 and table SPM 1. This evidence for human influence has grown since AR4. It is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. Left curly bracket 10.3-10.6, 10.9 right curly bracket. Land surface observations Fig. 60. Figure SPM 6 vertical line. Comparison of observed and simulated climate change based on 3 large-scale indicators in the atmosphere. 60. Page chooser. Page chooser. Page 17. Bullet and bullet there has been bullet there has bullet and bullet and bulleted it bulleted as bullet there future global and regional climate change.
So, this report, as I've said a few times, is from before 2014. It's actually dated 2013. So just like the issue with climate models, it has things to say, but I don't want to spend too much time on what a 7-year-old report says about the future, because it's 7 to 8 years later. Lots of data has continued to be gathered. In fact, there's been an acceleration in the amount of research being done on climate science, as they have commented on themselves. And so again, I'll cut through these briefly, just so you can see them, and if you want to come back and look at them either on the video or in real life on their website, that's of course your capability.
Projections of changes in the climate system are made using a hierarchy of climate models ranging from simple climate models to models of intermediate complexity to comprehensive climate models and Earth system models. These models simulate changes based on a set of scenarios of anthropogenic forcings. A new set of scenarios, the representative concentration pathways (RCPs), was used for the new climate model simulations carried out under the framework of the Coupled Model Intercomparison Project Phase 5, CMIP5, of the World Climate Research Programme. In all RCPs, atmospheric CO2 concentrations are higher in 2100 relative to present day as a result of a further increase of cumulative emissions of CO2 to the atmosphere during the 21st century. See box SPM 1. Projections in this summary for policymakers are for the end of the 21st century 2081 to 2100, given relative to 1986 to 2005, unless otherwise stated. To place such projections in historical context, it is necessary to consider observed changes between different periods. Based on the longest global surface temperature dataset available, the observed change between the average of the period 1850 to 1900 and of the AR5 reference period is 0.61, 0.55 to 0.67, 0 degrees Celsius. However, warming has occurred beyond the average of the AR5 reference period. Hence, this is not an estimate of historical warming to present. See Chapter 2.
So there. Notice as they mention the RCPs, and that all of them have higher warming rates than we currently have, but of course they're all time posted at 2100. Even the lowest one, the 2.6, I believe it was, has a higher what was it, 422 parts per million, as opposed to we currently have 390 parts per million, so it is a higher concentration than we currently have. So part of that. Much more importantly, so that vinyl we're listening to right now, and that terrible scratch, is like one of the worst scratches I have in any of my records, because I'm glad you can't see me right now. There's a tear rolling down my face. This is the reason why they convinced us to start buying CDs, guys. It's because our records had scratches on them and skips. Anyway. Sigh. Anyway, onward.
Bullet project. Continue. 17 of page chooser. Page 18. Global bullet projected E. 1 atmosphere temperature. Bullet the global mean surface temperature change for the period 2016 to 2035 relative to 1986 to 2005 will likely be in the range of 0.3 degrees Celsius to 0.7 degrees Celsius. Medium confidence. This assessment is based on multiple lines of evidence and assumes there will be no major volcanic eruptions or secular changes in total solar irradiance. Relative to natural internal variability, near-term, increases in seasonal mean and annual mean temperatures are expected to be larger in the tropics and subtropics than in mid-latitudes. High confidence. Dart. Left curly bracket 11. Bulleted E. 2 atmosphere, water cycle. Bullet projected changes in the water cycle over the next few decades show similar large-scale patterns to those towards the end of the century, but with smaller magnitude. Changes in the near term, and at the regional scale will be strongly influenced by natural internal variability and may be affected by anthropogenic aerosol emissions. Left curly bracket 11.3 right curly bracket. Global changes 18 of 20. Page 8. Change. Global surface temperature change for the end of the 21st century is likely to exceed 1.5 degrees Celsius relative to 1850 to 1900 for all RCP scenarios except RCP 2.6. It is likely to exceed 2 degrees Celsius for RCP 6.0 and RCP 8.5, and more likely than not to exceed 2 degrees Celsius for RCP 4.5. Warming will continue beyond 2100 under all RCP scenarios except RCP 2.6. Warming will continue to exhibit interannual to decadal variability and will not be regionally uniform. See figures SPM 7 and SPM 8. Left curly bracket 11. Changes in the global water cycle in response to the warming over the 21st century will not be uniform. The contrast in precipitation between wet and dry regions and between wet and dry seasons will increase, although there may be regional exceptions. See figure SPM 8. Left curly bracket 12.4 18 of 28. Page chooser. Page 19. Figure SPM 7 vertical line. CMIP5 multi-model simulated time series from 1950 to 2104. 19. Page chooser. Page 20. RCP2, RCP, share, SP, mark, cert, bookmark. RC 20 of 28, page chooser. Page 20 of 28, page chooser. Page 21. Bullet globally, bullet the hub, bullet X, bullet globe, bullet there, table SPM, 2 vertical line. Projected change in global mean surface air temperature at 2046 2000 scenario mean likely global mean surface temperature page chooser page 21 page 22 bullet the range in project E 3 atmosphere bullet the range in E 3 atmosphere air quality bullet the range in projections of air quality ozone and PM 2.517 in near surface air, is driven primarily by emissions, including CH4, rather than by physical climate change. Medium confidence. There is high confidence that globally, warming decreases background surface ozone. High CH4 levels, as in RCP 8.5, can offset this decrease, raising background surface ozone by year 2100 on average by about 8 ppb, 25% of current levels, relative to scenarios with small CH4 changes, as in RCP 4.5 and RCP 6.0. High confidence. Left curly bracket 11.3 right curly bracket.
I'll be honest, I'm a generalist, and I'm not a chemist. I'm more of a physics background, so this is not my strength, and it's also the future. And so, as I said, we're not lingering too long.
Bullet observation. 4 Ocean. Bullet The strongest ocean warming is projected for the surface in tropical and northern hemisphere subtropical regions. At greater depth the warming will be most pronounced in the Southern Ocean, high confidence. Best estimates of ocean warming in the top 100 meters are about 0.6 degrees Celsius, RCP 2.6, to 2.0 degrees Celsius, RCP 8.5, and about 0.3 degrees Celsius, RCP 2.6, to 0.6 degrees Celsius, RCP 8.5, at a depth of about 1,000 meters by the end of the 21st century, left curly bracket 12.4. Bullet It is very likely that the Atlantic meridional overturning circulation, AMIC, will weaken over the 21st century. Best estimates and ranges 18 for the reduction are 11%, 1 to 24%, in RCP 2.6 and 34%, 12 to 54%, in RCP 8.5. It is likely that there will be some decline in the AMIC by about 2050, but there may be some decades when the AMIC increases due to large natural internal variability, left curly bracket, bulleted E5 cryosphere. Bullet year-round reductions in Arctic sea ice extent are projected by the end of the 21st century from multi-model averages. These reductions range from 43% for RCP 2.6 to 94% for RCP 8.5 in September and from 8% for RCP 2.6 to 34% for RCP 8.5 in February. Medium confidence, see figures SPM 7 and SPM 8. Left curly bracket, the global ocean will continue to warm during the 21st century. Heat will penetrate from the surface to the deep ocean and affect ocean circulation. Left curly bracket 11.3. It is very likely that the Arctic sea ice cover will continue to shrink and thin and that northern hemisphere spring snow cover will decrease during the 21st century as global mean surface temperature rises. Global glacier volume will further decrease. Left curly bracket 12.17 p. 18 the 22 of 28. Page chooser. Page 23. SPM summary for policy markup. Cert. Bookmark. Bullet based on an bullet in the bullet by the bullet the air bulleted as E6 sea level. Bullet based bullet bulleted E6 sea level. Bullet confidence in projections of global mean sea level rise has increased since the AR5 because of the improved physical understanding of the components of sea level, the improved agreement of process-based models with observations, and the inclusion of ice sheet dynamical changes. Left curly bracket 13.3-13. Bullet global mean sea level rise for 2081 to 2100 relative to 1986 to 2005 will likely be in the ranges of 0.26 to 0.55 meters for RCP 2.6, 0.32 to 0.63 meters for RCP 4.5, 0.33 to 0.63 meters for RCP 6.0, and 0.45 to 0.82 meters for RCP 8.5, medium confidence. For RCP 8.5, the rise by the year 2100 is 0.52 to 0.98 meters, with a rate during 2081 to 2100 of 8 to 16 millimeters. Year 1, medium confidence. These ranges are derived from CMIP5 climate projections in combination with process-based models and literature, assessment of glacier and ice sheet contributions, see figure SPM 9, table SPM 2, left curly bracket, bullet in the arse, bullet base. Global mean sea level will continue to rise during the 21st century. See figure SPM 9. Under all RCP scenarios, the rate of sea level rise will very likely exceed that observed during 1971 to 2010 due to increased ocean warming and increased loss of mass from glaciers and ice sheets. Left curly bracket the 19 conditions in the 23 of 20. Page chooser. Page 24. 1.00 figure SPM. Share S mark search bullet C E bullet ocean bullet bay 1.0 figure SPM 9 vertical line Projections of global mean sea level rise over the 21st century. 20. Page chooser. Page 24. Page 25. Library. S. Markup. Cert. Bookmarks. Bullet Earth System Model. Bullet Cumulative. Bullet by 2000. Bullet the release of E. A. Climate stabilization. Climate change commitment and irreversibility. Bullet cumulative total emissions of CO2 and global mean surface temperature response are approximately linearly related. See Figure SPM 10. Any given level of warming is associated with a range of cumulative CO2 emissions 21, and therefore, e.g. higher emissions in earlier decades imply lower emissions later. Left curly bracket 12.5 right curly bracket.
Now that comment, I've looked at this a couple times. Higher emissions in an earlier, lower emissions later suggests to me they're talking about stabilization. Frankly, I didn't really understand this particular paragraph. If you can understand what they're saying, please drop me a line.
Bullet limiting the warming caused by anthropogenic CO2 emissions alone with a probability of greater than 33%, greater than 50%, and greater than 66% to less than 2 degrees Celsius since the period 1861, 188022, will require cumulative CO2 emissions from all anthropogenic sources to stay between 0 and about 1,570 GTC, 5,760 gigaton CO2. 0 and about 1,210 GTC, 4,440 gigaton CO2. And 0 and about 1,000 GTC, 3,670 gigaton CO2, since that period, respectively 23. These upper amounts are reduced to about 900 GTC, 3,300 gigaton CO. Table SPM, 3 vertical line, cumulative CO2 emissions for the 2012 to 2100 period compatible with the RCP at scenario. Cumulative GT gigatons mean rate up to 195 RCP bullet limiting the warming. Page chooser.
This is a case
Page 25.
where looking at the chart,
Adjustable.
I'm sure will be much clearer than listening to that. I could be wrong.
Page 26. Bullet hair large. Bullet hair. Bullet hair. Bulleted. 54321. 20. Figure SPM. 10 vertical line. Global mean surface temperature increase as a function of cumulative total global CO2. 20. Page chooser. Page 26. Page 27.
And this is where we started. Congratulations. I'd send you a certificate, but I'd have to make one, and, well, you know.
App switcher. Books. Files. Safari.
So,
Safari.
if you want,
Safari.
I can send you my copies of any documents, though I don't know why
The physical science
you
basics.
necessarily want
Heading
mine.
level 1.
As I said, the addresses for both the page to find this stuff and also a lot of the actual download pages themselves will be listed in the comments. Pardon me. If it's not accessible to you for some reason, for example, if you're watching this on Apple TV where you don't see the comments, I am willing to send you the information, even send you the comments information with all the links, because this information is there on their website. And if you have questions outside of this, if you look at the Understanding the IPCC meetup page, which was at the very beginning of this video, if you need to go back and check it out, I will be setting up question and answer sessions there related to each presentation. So thanks ever so much, and I hope this has been useful for you.
3 of 3 Wi-Fi bars. Control center. V. Ed. Wi-Fi. Bluetooth. Show. Previous. Pause. Next. Mute. Do. Brightness. Volume. Screen mirror. Apple T. Selected. Screen recording. Button.